Okay, the question is 2 cos brackets x plus 50 equals sine x plus 40. And underneath it, I wrote tan x equals a third tan 40. But I'm not quite sure what I was getting out of this question.
So you... What did you write, sorry?
Actually, I think the tan part is irrelevant because I started solving this.
Okay. And so how do you start solving it?
So you use the compound formula for cos x plus alpha.
Okay.
So it's 2 cos x cos 50 minus 2 sine x sine 50 equals sine x cos 40. 2 sine x cos 40 plus sine 40 cos x.
Yep. Any idea what you do next?
You what I managed to do in my working was convert the cos 40 into sine 50.
Cos 40 into sine 50, yes.
How does that work?
So put into your calculator sine 50.
Yep.
What is it?
0.766.
Put into your calculator cos 40.
Yep.
Is it the same?
Yep.
Put into your calculator sine 1.
Yep. 0.175.
Put into your calculator cos 89.
The same thing.
Yes. What are they called? Complementary angle? No. Yeah, complementary angles. Basically, they both add up to 90. So basically,
Right.
sine A is equal to cos 90 minus A and vice versa. And so sine 1 equals cos 89, sine 2 equals cos 88, sine 3 equals cos 87, and vice versa. Cos 1 equals sine 89.
Yeah.
And so on. And so yeah, go on.
Oh, is that something that I should be particularly looking out for in questions like these?
So not a whole lot. Technically, it can come up more in the second year of A level. Technically, it also could have in the old spec. It just rarely did. Technically, it could have come up at GCSE. It just very rarely did. But yeah, almost nobody is aware of it.
Right.
It's not emphasized, but it doesn't come up very often. But yeah.
Yeah. Okay. So from here, I did cos x cos 50 minus 2 sine x sine 50 equals sine x sine 50 plus cos x cos 50.
Okay. So you changed all the causes to sines, was it?
I changed on the right hand side. I changed this cos to sine, yeah, and the sine to cos.
But we still have
Oh.
a cos x. Is that right?
The first sine is sine. The first one is still cos 50, not sine 40.
Okay. Yeah. Okay, so what would we do next?
What we were shown was to equate it to 0.
Right.
So I got cos x cos 50 minus 3 sine x sine 50 equals 0.
Right. Then what?
So I simplified that down.
What's the simplified down to?
Cos x cos 50 minus 3 sine x sine 50.
Yeah. Okay, so I'll stick with the thing. Minus 3 sine x sine 50, was it?
Yeah.
Okay.
And then from here I brought over the sign to make it positive. Cos x cos 50 equals 3 sine x sine 50.
Mm-hmm.
And from here, my working seems to have ceased.
What would happen if you divided both sides by sine? So divide both sides, and we'll do it all in one go, by sine x, sorry, by cos x cos 50.
Okay. So the left hand side would be equal to 1.
Mm-hmm.
And the right hand side would be equal to 3 tan.
So 3 tan x, anything else?
3 tan x. No.
Sine 50 over cos 50?
Oh, tan 50.
Yes. And I'll just swap those two around, and so it's tan 50 tan x.
Mm-hmm.
Okay, what's next?
So we can factorize it.
Nope.
And we... No.
It's not times tan. Tan isn't a common factor.
Divide by 3, I guess.
Yeah, and do it all in one go. What else will you divide by next?
Divide by 3 and... arctan it.
Don't forget that tan x is just... Sorry, tan 50 is just a number.
So we can find tan 50.
Mm-hmm.
Which is 1.192.
Okay, and so you can just divide through basically by the numbers. So 3 tan 50.
3 tan 50.
So you could have divided by both sides by 3, then divided both sides by tan 50, or you can just do it in one go.
Okay, let me just make a note that tan 50 is just a number.
Yeah, sine 50 is just a number, cos 50 is just a number, tan 40, yeah. You know.
Okay, so from here we get 1 over 3 times 1.192 equals 3 10x over 50. 3 10 50.
So I have 1 over 3 tan 50 equals 10x.
Yeah.
Okay.
And then we arctan this.
Yes.
Okay. And that is 15.62.
67.
And 6. I get 15.62.
So you probably rounded too early. So this is, I just put the original equation into my solver.
Oh yeah.
At the very beginning.
Oh, so 0.63. When would I need to remember if it's plus or minus? Because we looked at that yesterday and the day before.
What if it's like plus or minus the answer? If something is squared, so if it's like x squared is 9, then x could be 3 or minus 3, because a minus squared becomes a plus. But there's nothing squared here. It's only in situations where you have like sine squared x or something like that.
Okay. One thing as well, because I was looking through from the start. When would I use cast? Because I've realised that I haven't been using it in the later stuff of what I've been doing.
So you always use it. You may not be aware of it. So how do you get how do you get a second answer for sine, cos, or tan?
Usually I look at the graph and then 180 plus or 180 minus.
Yeah. So the cast diagram is a simplification of those graphs on how to get your second answer. And that's all. That's all it is. I mean, I don't use the cast diagram. I don't even use the graph. I just remember 180 minus, 360 minus, 180 plus. Because the graphs never change. You know.
Yeah. I guess now a bit of double angle formulae and compound formulae practice.
Sure. However, let's just get one more solution for this one, just in case.
Okay.
What would be one more solution?
So since it's tan, it repeats every 180.
Yep.
So do you do plus or minus on this number? 180 plus or 180 minus 50.63.
And what would you get?
So you would get 195.63 is one of them.
Mm-hmm.
Or 164.37. No. If you're subtracting, so you do 15.63 plus 180, 50.63 minus 180, right?
Well done.
Okay. So minus 164.37.
Yes, and so I was just clarifying that bit at the end. So with the plus part, doesn't matter because 2 plus 3 is the same as 3 plus 2, but the minus part is different. It does make a difference which comes first, which comes second. Basically, it has to be 180 away. So okay, so you wanted what, compound angle formula and stuff?
Yeah. So yeah. Okay, so you would start by using the compound formula for cos something minus something.
That's long, man.
And
Is there a quick way of
sorry?
doing it? Is there a quick way of doing it?
Maybe.
What's a quick way of doing it?
Could you just subtract cos pi over 12 from cos theta minus pi over 18?
So cos pi over 12. Pi is just a number. Pi over 12 is just a number. Cos pi over 12 is just a number.
Oh, so you find what cos pi over 12 is?
Yep.
Okay. So 0.999989. That's very close to 1.
Are you in radians?
Nope. In degrees. What difference is it if it's in radian or degrees?
It's the difference between percent and degrees. It's just a different unit of measurement.
Oh, okay.
Like difference between hours and minutes.
So this one is root 6 plus root 2 over 4.
Oh, cool. Exact answer.
Yeah.
So cos theta minus pi over 18 equals, was it root 6 plus root 2
6, yeah.
Over 4?
Over 4. Yeah.
Okay. What's next?
Do you arc cos both sides?
Yep.
Theta minus pi over 18 equals arc cos of that. Which is equal to a 12 pi. Oh, yeah, of course. Could you just eliminate the causes?
Yeah, because there's that cause from the beginning, I suppose, yeah. Okay. Rarely comes up, but alright. Okay, what is next?
So you have theta minus pi over 18 equals pi over 12. So you just bring over the pi over 18.
Not yet. Not yet, you don't.
But there's no cos or anything.
What did I tell you? After you do arc, sine, cos, or tan, get
Oh yeah,
all of
you need to find the values then.
Yes. And let's do this one properly. So you know how we have theta is between 0 and 2 pi? What is theta minus pi over 18 between?
That's between minus pi over 18 and 2 pi minus pi over 18.
Yeah. And whatever 2 pi minus pi over 18 is. I think it'd be 1 and 17 over 17 pi over 18, something like that. 35 over 18 pi?
35 over 18, yeah.
Yeah, so this is as an improper fraction. Okay. What's next?
So you have that sequence. So you can draw the graph, or I would usually draw the graph. That's a cos. If I were to make minus pi over 18 into a number, could I use that on the graph like I normally would in degrees?
How do you get your second answer for cos? So we've got one answer, pi over 12. You want second answer?
Yeah. Um, oh. You subtract it from 360, so 360 minus that, so it's 2 pi minus that.
Boom.
So 2 pi minus pi over 12. Which is 23 over 12 pi.
Yeah. And screw it. I'm leaving that as 1 and 11/12 pi.
Okay.
Okay. Can we get any more answers in the range?
So it is minus 18. Could we check for the lower bound?
Sure.
So we have that. Then we do. So we do 180 minus that.
Nope.
Minus.
From now on, they just repeat every 360 or every 2 pi. But basically, the cos graph is symmetrical.
Yeah.
So cos is special. So plus or minus pi over 12, plus or minus 1 and 11/12 pi. Not because it's squared, just because it's symmetrical. So you get 4 answers.
Okay.
However, are the negative ones in the range. So minus 1 and 11/12 pi is way outside the range. Minus pi over 12, is that inside or outside the range? Our range goes down to minus pi over 18.
Minus pi over 12 minus pi over 18. Minus pi over 12 is too big.
Yes, or I suppose too small. Yeah, 1/18th is smaller than a 12th, and so we've only got these 2 answers in the range.
Okay.
Okay, is that full marks?
2, 1, 2.
Are those the answers?
No, they're not. We then add pi over 18 to them?
Yeah.
Okay. So that's pi plus pi over 18, which is 5 over 36 pi. And 23 pi over 12. So 2 pi.
It's close to 2 pi, but it's not quite, is it? 23 pi over 12?
It gives me 2 pi as an answer.
Oh, is it really?
Isn't it just like 24 over 12?
I don't know. What was it? Plus 1 pi. Yeah, that's exactly 2 pi. There you go. Great. I was adding a different thing. It's in my head. So that's 2 pi. And the other one was 5 pi over 36?
Yes, 5 pi over 36.
Okay, great. Let's see. A more direct way of doing it is by cheating. I want to see what happens if I try cheating.
Sure.
So cos alpha x minus shift pi over 18, and I could do fancy stuff. I'm just gonna copy and paste the question. Cos shift pi over 12, close that bracket, shift solve equals 6.7195. Let me try that again. Shift solve, and I'll start with 0.1 or some low value. And I get a negative. Yeah, cheaters never win. Basically, the problem here is we've got exact values, and they said exact value. Only give a 3 sig figure when it's not exact. So I could use it to check my answer, but nothing better than that.
Why
Great.
would you use the minus 0.1?
I didn't. I used positive 0.1.
Oh, but what's the use of it?
I just thought I might get something like low or something. So if I do
Oh,
shift solve, let's say I start from 1 or something.
oh, so x equals 1.
So 0.436. So what is 5 pi over 36? Press SD.
0.36.
It's
436.
yeah. So that's this one. 0.4363323.
How, what I'm a bit confused about is how you're able to choose 1 and 0.1. Like where are the numbers coming from?
Sorry. So when you press shift solve?
Yeah, my one does it differently, but yeah, sure.
Okay, so you have to choose some initial value. So it's like when you're doing iterative formulae and they have to tell you like x0 is 3. And so you press 3, press equals, and that's your first answer in your calculator. So you need some initial value to start you off. So they'll say find x1, x2, x3, x4, but x0, they have to tell you what it is, 2.5 or something.
Oh, okay.
And so this calculator just takes some initial value. So you can say, okay, start from 2 and go from there.
I don't know. I don't have that, my one, but
All right. It's just an initial value. And I'm just
okay.
guessing some initial value, 1, 2, some of that.
Okay.
Okay, part B.
So tan 2 theta equals 0.6. And we use the double angle formula thing.
You love that double angle thing.
Well, yeah, because that's what we're taught to use.
So, what's easier than double angle?
Finding the arctan.
Yes. And the reason why you use this double angle stuff and r sine x plus alpha is so that you can solve it. So
right.
that you can just inverse sine both sides or inverse tan or whatever.
So how would you know when to actually use it?
If you're trying to solve it.
But here aren't we trying to solve it?
Yep. Oh, so, well, they usually tell you, like, put it in the form of r sine x plus alpha or something. That's part A, and then part B will say hence solve. So it's like we're doing the part, B.
Yeah, I'm just confused because this doing the arctan just completely knocks off the whole point of doing the double angle formula, right?
So we're trying to find out what theta is.
Yeah.
The tan of 2 times something gives us 0.6. So we're trying to find out what theta is, what number it is. So
yeah.
The usual way, GCSE way or something, would be like subtract from both sides, divide from both sides, all that stuff. Here we do arctan both sides, then divide both sides by 2, and we'll go. We'll do it like that. If you were to put tan 2 theta, what is the tan 2 theta using the double angle formula for tan? Do you know?
I don't have it on hand. I haven't memorized it.
So I think it's going to be something like tan squared theta over 1 minus tan squared theta or something like that.
Mm-hmm.
So which of those equations is easier to solve? Tan 2 theta or that monstrosity?
I think the first one.
Yeah, so the whole point is that you make it look like this first because it makes it easier to solve.
Okay.
So
how?
The part A is usually they would give us some monstrosity like tan squared theta over 1 plus tan squared theta, and they would say prove that is actually tan 2 theta. And then
I see.
And then they'd say part B, hence solve. And you would say, well, I'll just solve the easy version, not the difficult one.
Yeah, Okay, I understand. Sorry.
Yeah. And so this is just cutting straight to the solving part.
Yeah. Okay, I understand now.
All right.
So here we do arctan of both sides.
All right. And again, I'm cheating.
Mm-hmm. So 0.540, and we divide both sides by 2. 0.270, and that's theta.
I have taught you nothing.
Oh, I need to do the arc. Yeah, I need to do the arctan thing before I simplify it furthermore.
And in fact, let's get our range so we get all our answers.
Mm-hmm.
So what is 2 theta between?
So 2 theta is between 0, because you can't do 0 over 2, and pi.
A half theta that'd be a half theta. We're going the other way. What do you have to do to theta to turn it into 2 theta?
So it's 4 pi.
Yeah.
4 pi. Okay. That's our range. Okay, so you have 0.540, and it's tan, so you just subtract 180.
Yeah. Or what is 180 in radians?
Pi.
Yep.
Let's do pi plus or minus that. Pi plus 0.54. So 3.68 pi minus 2. And I need to convert that into pi.
No. So was your first one 0.54042?
0.540, yeah, 42.
So they said final answer to 3 sig fig, so I'm using 5. So you're doing that plus pi.
Yeah, which I got to 3.68159.
Okay.
It may be, the last few numbers may be a bit different because I used 0.540, which I probably shouldn't.
Yeah, so we'll just keep it as 5 sig fig. So 3.6820.
3.6820. And yeah, then 2.60117 for pi minus 0.50.
Be outside the range, wouldn't it?
Yes, because is it?
Remember, it's not pi minus. It has to be pi away from it. So
it's the thing minus pi.
yes.
Yeah, which would be below 0.
Yeah. So we won't be getting any negative answers.
No. And we want to know if we've got all the values. So do we calculate what 4 pi is?
Sure.
So that's 12.5. So we could just keep on adding pi to the values that we have. So 3.68201 plus pi 6.82360. We have pi again. 9.9652 is pi. And that's too high. So these are our values.
Okay.
And then we subtract. No, we divide it by 2.
Yeah.
So we get 1.841 3.4118 4.9826.
And your first one was it 0.27021?
The first one. Oh, I forgot to do 0.5.
So yeah, I didn't hear that one. So I'll go and try it there, see if that's what you get.
0.54. What about you? Yeah, 0.27. 4042 actually.
And then after that, was it 1.8410?
1.81. 1.841.
Yes, that's fine. And the rest, so on. Any questions there?
No.
Okay.
I think I just need to remember after arcsine you do the graph. You find on the graph.
Yes, and actually, silly me, these should all be rounded to 3 sig fig at the end. 270, 1.84, 3.41. Yeah, okay. Yeah, so once you do the arc sine cos or tan, then you just keep them the same. Find the value of tan x. Okay, it's a good one. Hang on, before we do this, should we do more solving or more specifically this is or more specifically the double angle? That's kind of, well, looks like that's it. So hang on. Yeah, do you want more solving
double angle
or double angle stuff?
What we've just been doing is more solving, right?
Yeah.
Okay. Maybe if we do move on to double angle and compound, so that I can see when it's used, and then I can learn.
Okay.
See when I do solving and when I actually do double angle compound.
And are you so addition formulae? Okay. So I'm just gonna go to here. Yeah. Let's give it that sin x. That show that using the angle addition formulae. Okay, yeah. Sin x plus alpha. Double angle formulae. Just want to find the exact value. So D express C. Oh, these are strange. Yeah, okay. Show that this is equal to the hint. Okay, so this is kind of similar. Yeah. Okay, question 5. How do we do this? Oops.
5. Okay. So we use the formulae for this, right?
Yeah. 3 cos. Hang on, I might go even further with it. Proving trig. No. Hang on. 2 sides. Yeah, sorry. I think this is a better one. Hang on. Let's do this one. Question 4.
Okay. So h theta plus 4 cos theta. Is this the same sort of thing as? Oh yeah, it is. Given that h theta is, yeah, there we go. r sine theta plus alpha. That's between 90 degrees. When is that value of r? Okay, so first of all we can find r by doing 2 squared, or the square root of 2 squared and 4 squared. And that gets you 2 root 5. So that's your r value. And it's sine and cos, so you can do tan.
No.
And it's no.
They put it in the form of r sine theta plus alpha.
Okay. So use the sine formula. So sine alpha equals 2.
Yep.
And cos alpha equals 4.
Mm-hmm.
So then we do 2 over 4 arctan.
Okay.
That's something I need to look out for.
I don't think
So I always
so. Isn't
Sorry?
isn't it sine theta plus alpha? I believe is sine theta cos alpha.
Yes, it is. I've been thinking about cos. So yeah, it's 4 over 2.
Yep.
Oh, okay. I thought I said that, but maybe not. 4 over 2. So 1.107.
And what was alpha 2 decimal places?
Alpha 2 decimal places is 1.1. Yeah. So that would give you r sine theta plus 1.1.
That's 1 decimal place, isn't it?
Oh, it's 2 decimal places, so 1, 1.
Yeah.
So yeah, r sine theta plus 1.11.
What is r?
R is 2 root 5.
Yes. And so you'd have them both in. So 2 root 5 sine.
If your value of alpha exceeded 90 degrees, would that mean that you must have done something wrong?
Yep.
Okay. And now B. So 2 sine. Hence, so 2 sine theta plus 4 cos theta equals 3. So we can use 2 root 5 sine theta plus 1.11 equals 3. And first of all, we can divide both sides by 2 root 5.
Yep.
1.11 equals 3 over 2 root 5. And we can arc sine this and use that value to find them for now.
Yep.
1 equals arc sine over 2 root 5. Which is equal to 0.735 radians.
Oh, hold on. Change back into degrees now.
Okay. So I could just multiply this by 180 over pi, right?
If you like.
So 42.13 degrees.
Okay.
And this is a sine graph between 0 and 360, yeah. But we need to change the boundaries. And we subtract 1.11? Or is it add 1.11?
What would you have to do to theta to turn it into theta plus 1.11?
You add 1.11.
Yep.
So the boundary is 1.11 theta plus 1.11 of 361.11. And there will be two values, and you just do 180 minus 42.13, which is 137.87.
Hold on.
Yeah.
Arctan 2 in degrees.
Sorry?
1.11 is in radians.
Yeah, that's what I just thought.
Yeah, 63.44. No, 63.43.
Why do you arctan?
Because when we did arctan at the start for alpha, we were in radians. But this question is actually degrees.
Yeah, that's. I was starting to get onto that because I was thinking the difference is a bit small.
Yeah.
Okay, so arctan 4/2, which is equal to 63.43. So yeah, we just change everything to 43. 63.43. And then 360 plus 423.43. Okay, so that gives us more answers. 360.
So our first answer was 42.130. How do you get a second answer?
You do 180 minus that.
Yeah, what did you get?
137.87.
137.87?
87. Yep.
Okay.
Then the next one is 360 plus 42.13, which is 402.13. And that is pretty much as big as you're going to get.
Okay. And so then what do you do?
You subtract 63.43 from each one.
Yep.
So it's 42.13 minus 63.43. Which is minus 21.3. So 74.44. And 338.7.
Okay, so what were the answers?
So my answers are minus 21.3, 74.4, 338.7. Minus 21.3 is too small.
Yes, and so the minus one is too small, and so it starts from the 74 point whatever.
Yeah.
And goes from there.
Okay.
Yes, so I think there were two solutions in total.
Yeah.
Yeah. Any questions there?
No. It's just
So
a
this one,
question.
they give you this difficult things. So you can see part B would be a difficult thing to solve. But part A says first put it into the form of r sine theta plus alpha, and then part B says hence solve.
Yeah.
And so you use your form of r sine theta plus alpha. So if you have it in that form, you don't take it out of that form into something more difficult. But you can see how the structure of the question kind of helps you.
Yeah.
And that's quite common.
Okay.
Let's see. So we did tricky stuff. So this one, yes, they add up to 90. Cos 50 is the same as sine 40. Sine 1 is the same as cos 89, and so on. After you do arc cos arc sine arc tan, just keep it the same. Get all your solutions first. And although it hasn't made a huge deal, change the range. To make sure you get all the answers. Actually did make a huge deal for this one. It went from being 2 pi to 4 pi.
Yeah.
And so we got many additional answers, like double the number of answers. Let's see this one. And then, yeah, r sine theta, so you're good for that. Yeah, and if it's helpful, you can just look up the double angle formula or the compound angle formula, so that you can see, like, is it arctan the second over the first or the first over the second type of thing.
Yeah, yeah.
For this one, you initially said the other way around. Yeah, cos is the same and then sine is the opposite. But let's see. So it's a huge amount of stuff for trig, lots of different stuff. Here's proving trig identities. That's just same thing. Like this is what cos something is cos alpha is root 3, sine alpha is 1, and just doing it that way. Yeah.
For that one, if you just go back up to it, sorry.
Yeah.
Would you solve it in the form r cos x plus alpha? Yeah, I see that.
Yeah, and you could even work in reverse, that way. Like root 3 plus 1 squared square root or whatever.
Yeah.
That's 2. Yeah. How was that for you, Gregoire?
It was good, thank you. Yeah.
And and you have a test on this stuff, is it?
Yeah, it's tomorrow, so I think after this I'll just do a bit more consolidation.
Okay. Actually, I forgot to book this lesson in. I'll probably just book in a lesson for like 9 o'clock tonight and just...
Oh, sure.
And so, anything in particular for next time?
I'm not too sure, considering we're doing...
Okay.
We're definitely continuing with Trig after this week, I think.
Yeah, because there's a lot to do with Trig. Yeah.
Yeah.
All right. Any questions for me in general?
No, I think that's it.
All right. Well done, Gregoire. You did great. And